Okay. Hello, hello. My name is Jerry. I'm going to be your instructor today. And what we're going to spend this free prep hour looking at are what I'll call funky functions. What do I mean by that? I mean, sometimes in the GRE, we see these weird functions. And this is called just a function. It might be familiar to you from math class at some point. Or it might be stranger, where they give you some symbol you've never seen and tell you how to do it. Or this weird notation of sequences. So these are the three things we're going to deal with. And all three can seem kind of intimidating at first, but ultimately it's just about understanding how the notation works and following the directions without panicking. So that's what we're going to work on today. So just to kind of throw us in, got a little warm-up problem here. Try this out, do your best. If you have no idea how to do it, that's totally okay. We'll walk through and we'll learn how these work as we go. Okay, so here we've got this f of x. And what that means is we've got a function where for any x I plug in, this is what the function does. The function's like a little machine. I put in x and it spits out x squared plus 1. And so the key with these is just whatever we see inside the function symbol, we just replace x with that. So we're looking for f of 2 plus f of negative 2. Well, f of 2 is going to equal 2 squared plus 1, which would be 4 plus 1, so 5. And f of negative 2 would be negative 2 squared plus 1, which is also 4 plus 1, so 5. So notice what I did here, right? I just rewrote it, including the parentheses here. And just wherever I see x, I put with parentheses, helpful to do that in case we have negatives, whatever's inside there. And it doesn't matter if it's 2 or 2x or 2x plus 7, whatever's in there just goes wherever the x is. So I'm looking for f of 2 plus f of negative 2. That's going to be 5 plus 5. So my answer is B, 10. So we're going to keep working with these for a bit, getting a little bit more complicated as we go. The goal is getting comfortable using these to the point where we're going to see how they can get more complicated, and then we'll move on to those other problem types that I showed you at the beginning. Try this one out. So here we've got a little bit more complication, right? So we have this function h of x, which spits out 2x cubed minus 3. And then they give us a value. They say h of m is negative 19 and ask for the value of m. Well, we just need to use this equation here and say, all right, h of m, well, I know what that is. I just, wherever I see an x, I put an m. So 2m cubed minus 3. And they tell me that equals negative 19. Great. So 2m cubed equals, I'm going to add 3 to both sides, negative 16. Let's divide both sides by 2. Now, okay, to get m by itself, what's my last step? I've got to take the cube root of both sides. Now, because this is negative, I should already know that my answer, m, has got to be negative. Because this is an odd value, something, a negative number to an odd exponent is going to stay negative. So I can get rid of these positive answers. And if I'm unsure of what the cube root of 8 is, and my calculator won't let me do it, well, I could try both of these and see which works. And if we do that, we might realize, okay, 3 cubed, 3 times 3 is 9, times 3 is 27, so that would be negative 27. That's not it. Negative 2 cubed, 2 times 2 is 4, times 2, 8. So negative 8, aha, that's our winner. Or maybe you just know that the cube root of 8 is 2. Going with the theme of not panicking, I think this is a case where you're like, oh my God, I've got a variable to the third. What am I supposed to do about that? Try to see what answers you can eliminate, work from the ones that are left. Let's keep going. Okay, so quite similar to the last one in terms of its structure, but it's just a little bit more complicated given where they want us to go with it. So they give us this function, put in x, it spits out x plus 5. And then they tell us when we put in 2g, we get 19. Great. And then we're asked about what happens when we put in 3 minus g. So just looking at this, we might say, okay, well, I need to figure out what g is. So let's start there. If I know f of 2g is equal to 2g plus 5, and I know 2g plus 5, f of 2g is equal to 19. So now I can solve for g. Subtract 5 from both sides. Divide by 2. Great, so g is 7. And now I want f of 3 minus g. going to be f of -4. Okay. So now for f of -4, I know that's just going to be -4 plus 5, which would be 1. And that's my answer. If these are starting to feel easy, great. Again, this is not the kind of problem you're going to see a million times in the GRE. But if you see it, you might as well know how to do it. And, you know, what the functions look like and what they ask you to do with them can get a little more complicated, but it's ultimately this same technique. So if this technique is starting to feel clear, great. So let's up the difficulty a little bit. Okay, so this one has a little bit of a different thing going on, right? So now we've got a function with 2 variables in it. You might see this, you might see 3, you might see 7, and you're not going to see 7, but they tell us for A and B, this is what we do to them. Square A, put B to the 4th. And now, okay, we've seen this kind of thing before where they give us the number, they give us the variables, we got to find the variables and then go here. So f of mn, we know is equal to m squared n to the 4th, and we know that's equal to 5. Well, okay. Could I solve for m and n here? No. So why can't I? Because if I took the square root of both, well, simpler reason, 2 variables, only 1 equation. And if I have 2 variables, I would need a second equation. And you can watch the free prep hour on 2 variable word problems if you want more explanation about that. But so we can't actually solve for m and n. what do we need to do instead? Let's take a look at what's going on here. F of 3m 2n. What's that going to equal? So 3m squared times 2n to the fourth. I'm going to distribute this squared, so that becomes 9m squared. Distribute this to the fourth power times 16n to the fourth. Okay. Well, I know I see m squared n to the fourth, and I see m squared n to the fourth. So, okay, maybe I can start to use this to solve this. So let me combine some like terms here. We'll do 9 times 16 gives me 144 m squared n to the fourth. And aha, I know what that is. 5. So now I can just do 144 times 5 gives me my answer of 720. So a couple things here. One, we see a function with more than one variable. Second is, if we see something where I can't actually get the variables, try to think about, okay, is my answer in terms of those variables, or can I substitute a chunk of information, even if I don't have the individual pieces? Again, goes under the category of don't panic when something weird happens in a question. Try to just keep working with what you have and where you're going. A little bit tougher now. Okay. So again, same idea, but using it in a slightly more complicated way, because now we're inserting two variables into a one variable function. That's no problem for us. We know how to do that. a plus b, wherever I see an x, I just put a plus b. Now, a little aside about a plus b squared. Lest you think a plus b squared is equal to a squared plus b squared. If you think this, you are sorely mistaken. So it's worth just foiling it out in case this is new to you. A plus b squared is equal to a plus b times a plus b. And like any pair of binomials, we have to use FOIL, right? So a times a plus a times b plus b times a plus b times b. And what that's going to give us is a times a is a squared plus B times A, or sorry, so A times A times B, which is AB, plus B times A, which is also AB. Doesn't matter which order you write it in, BA or AB. So I'm going to keep it the same. Plus B times B, which is B squared. And this gives us our perfect square formula, which is worth memorizing. A squared plus 2AB plus B squared. Okay, so to come back down here, we've got 5A squared plus 2AB plus B squared plus A plus B. Let's distribute that 5. And then that's all she wrote. Can't combine anything more. And we look down here, and that, thankfully, is exactly as we have it in choice E. So again, involving some other skills, some quadratic skills, right? And that's the thing, one of the things about a function problem. It can kind of call on any math. It's just about following the directions, and then whatever they put in there is going to be whatever they also feel like testing you on. But again, under the category of don't panic, we haven't seen something like this, but hey, we treat it exactly the same as anything else. Wherever we saw an X, put A plus B. Let's keep going. Okay. So here we have one more complication. 2 different functions. And now we've got a kind of nested function. But let's just start here and try to unpack it. Because what we'll see is, okay, h of x is 2x minus 1. We're looking for h of g of 5. So h of g of 5 is going to be wherever I see x, I put g of 5. Okay. And I can figure out what g of 5 is. This we really know how to do. Okay. And now I know g of 5 is 22. So I can just go back here. 2 times 22 minus 1. 44 minus 1 gives us 43. So in general with these, work from the inside out. And you might even see multiple layers of this. It could be g of h of g of 5, in which case we would take that 43 and put it back into G, and it would just be G of 43 essentially, because we know H of G of 5 is 43. So it's just the same thing. You work from the inside. I get G of 5, I get H of G of 5, I get G of H of G of 5. And let's just do that. We're here. Why not? G of 43 would be 43 squared minus 3. 43 squared gives us 1849 minus 3 would be 1846. Okay. One more in this vein, and then we'll move on to another topic. Okay. So here we've got our two different functions, but now they're not nested. We're looking for H of M, and to find that, we have to go by way of G of M. So in order to find M, I'm going to need to use these equations here. So G of M, which I know is 29, is going to be M squared minus 7, and that's equal to 29. So let's solve for M using that. I'll add 7 to both sides, take the square root, M equals plus or minus 6. Now, as we'll see, that's not really going to matter because we've got an absolute value here, but that's why that absolute value is here, in case you're wondering. So now we're looking for H of M. So H of 6 is equal to absolute value of 3 times 6 plus 2. And again, it doesn't matter if it's plus or minus here because of this absolute value. So that's why I'm just using the 6 here. So H of 6 is equal to 18 plus 2 is equal to 20. So again, even though these are getting more complicated, they're requiring more steps, the steps are all the same thing. It's just about understanding this notation, following the directions as they give it to you, working from the information they give you to find the information you need. Now, I'm going to change things up a little bit because so far all this notation has been very predictable. But something you might see is something like this. And it's easy when you see something like this to, again, panic. But as the moral of the story today is, don't panic. instead. Say, okay, I've never seen this symbol before. I don't know what this means. Well, that's because they just invented it. They're going to make up some function, some new mathematical symbol. So don't worry that you've never seen it. Just understand how it works. And ultimately, this is exactly the same as a function. They might as well be saying f of x is 2x squared plus 2, but they're using this weird upside down L. Cool. So we can follow this, we can figure this out. And then notice our answers are kind of annoying here, but I'll let you work on that in a second. Okay. So we're looking for which is equal to L4, call it L, right? So that L4 is going to be equal to 2 times 4 squared plus 2. So that's going to be equal to 2 times 16 plus 2. So 32 plus 2, so 34. All right, so which of these is likely to be equal to 34? This looks like a trap to me. So probably not going there. This looks way too big, right? Just thinking about squaring it and multiplying it by 2, that's going to be too big as well. So one of these guys. So let's start just square in the middle here. Often a good idea. Why not? So if I'm looking at B, so just to notice from a strategy standpoint, right? Something like this, I have no choice but to try these out. I eliminate what I can get rid of just sort of at first glance. And then I start in the middle because why not start in the middle? I maybe have a hunch already about where it's going to go, but if you're not totally sure, start in the middle. All right, so -2, that's going to equal 2 times -2 squared plus 2. Okay, so 2 times 4 plus 2. Already, this is not looking great. 8 plus 2 equals 10. Okay. So it's not B. It's going to be one of these two. Now, let's be a little canny here and say, all right, what does that -2 do here? The negative does nothing, actually. right? Because this is getting squared. So L2 is going to be the same as L negative 2. So I actually know already that C is going to be equal to L of L2, and L2 is 10. So this is actually L10. That's going to be too big. That's my hunch, right? L10, there's no way L10 is going to be equal to L4. So let's try A. Oops. So I'm extremely skeptical about C. So we'll try A. So L negative 1 is going to be equal to 2 times negative 1 squared plus 2. So 2 times 1 plus 2. Aha, it equals 4. So L of L negative 1 is actually going to be equal to L4. I don't even need to calculate it now. I know L4 is equal to L4, and I know it's equal to 34. A is going to be my answer. So a lot of stuff here, right? About following the instructions of how these functions work, but also about trying to be strategic about how we check answers, knowing that it's going to be time consuming, saying, how can we take as many shortcuts as possible? Here's another one, weird function. They're defining it for us. Try it out. Okay. So we've got box X is the least integer greater than X for all the odd values of X, and the greatest integer less than X for even values of X. Okay. So we want the value of box negative 2 minus box 5. All right, so this is tricky. This is really just about, can you follow these instructions and not panic? So take it one by one. So let's figure out first, what's box 2? Box 2, well, so 2 is an even number. So for even values of X, it's the greatest integer less than X. All right, so what's the greatest integer less than negative 2? That's going to be negative 3. Greatest integer less than is just a way of saying subtract 1 from it, right? What's the next one down? And then for box 5, this is odd. It's the least integer greater than X. So what's the next integer after 5? 6. Negative 3 minus 6, excuse me, equals negative 9, which is our answer. So this question is all about trying to intimidate you with this kind of stuff, with the fact that we've got an odd, that we've got an even, with the fact that you've never seen box X before. That's how they're getting you here. It's not like you don't know how to do -3 minus 6. Of course you do. It's that they give that to you in the weirdest way possible. So again, when you see one of these, take a breath, try to get really clear on how it works, break it into pieces. Don't worry about understanding the totality of box X. Follow its instructions for each individual number. One more of these, and then we'll move on to sequences. Okay, so here they give us star X, and then they're sort of mean, right? They spell it out rather than actually showing you in math. So we have to really follow the instructions here, which is, again, sort of all we're doing with these. So let me just translate this. Star X is defined as the square of 1/2 X. Okay, so 1/2 X squared. Not so bad. We want the value of star 5 over star 3. All right, so star 5 is going to be the square of 1/2 of 5. So 5 over 2 squared would be 25 over 4. Star 3, 3 over 2 squared, 9 over 4. 25 over 4 over 9 over 4. Dividing by fractions, just flip and multiply. 25 over 4 times 4 over 9. Oh, that's nice. I can cancel out these 4s. Nothing to cancel here. I get my final answer, 25 over 9. Again, none of this math is too hard. It's just about, can I follow these instructions? And that's all we have to do with the sequence problems as well, which we'll see the first one now. These are, again, all about understanding the notation. And they kind of explain it in the problem, but it's also one of these things where, like a function, it's worth being familiar with it. So I'll show you one, and then I'll show you how they work, and then you'll know how to do all of them. Okay. So we've got this sequence, which they define for any integer n greater than 1. And they tell us S3 and ask for S5. All right, well, what do we do with this? They're saying this is a sequence where each number, you take the previous number, multiply it by 2, and add 3. That's all that means. So we can think about kind of listing out the different numbers. And all this n is which number in the sequence are we dealing with? So S3, so S1 is our first term. S3 is our third term, which we know is 6. So to get S5, we just go step by step. First, I need S4. I take S3, multiply it by 2, and add 3. I take S4, multiply it by 2, and add 3, and I get my answer, 33. So once you understand this notation, you can do all of these. It's just about following the instructions, and it's about iterating. It's about starting where they starting from where they start you, and then moving step by step to where they ask you to go. So it's sometimes helpful to draw out the slots like this, and then understand how this terminology works, right? So the nth term, the previous term, the n plus 1 is the next term. And you move from what you know to what you don't know. So here's a little twist on that. Same sequence, but now I'm asking you to go backwards, back to S1. Try this out. Okay. So they give us S3. We want to get S1. How are we going to go backwards? Well, notice that the previous term shows up in here. So S3 is equal to 2S2 plus 3. Let's use that. And solve for S2. Subtract 3 from both sides and divide by 2. And then do it again. S2 equals 2S1, what we're going for, plus 3. Subtract 3 from both sides. Divide both sides by 2. Get our answer, negative 0.75, or if you used fractions, negative 3/4. do one more and then we'll wrap it up. So they give us our sequence, they give us our starting point, and they ask us for S5. So we're just gonna have to go through all these steps. And this can be kind of annoying or time consuming with these, that sometimes you just have to iterate the thing many times. So they tell us S1 is 6. And to go up, we're gonna multiply by 2 and subtract 4. So multiply by 2, subtract 4. So multiply by 2 equals 12, subtract 4 is 8. Times 2 is 16, minus 4 is 12. Times 2, 24 minus 4, 20. Times 2 is 40 minus 4, 36. And that's our answer. So sometimes it can be helpful if you do what I just did, right? And rather than writing it out, if you're able to, in your head, kind of speak it out, right? Say, okay, I multiply by 2 and then subtract 4. And think of it as like, okay, I do those steps again and again, rather than having to write out the whole thing. That said, if you need to write it out, do it, right? Better to get it right than it is to do it fast and get it wrong. So that is our lesson for today. Again, 3 kinds of problems that maybe feel really intimidating or confusing at first. But now that you've done them, done a lot of them, you might see, okay, they're not so bad. It's about not panicking, following the instructions, breaking it down step by step as you go. So thanks for joining me for this hour. I hope to see you at another one of these in the future. Happy studying.